Nuclear fusion and nuclear fission are two processes by which energy can be harnessed from atomic nuclei. While they may sound quite similar, these processes are fundamentally different in terms of their operation, products, and implications for energy production. Nuclear fission is a process that has been utilized since the mid 20th century. It involves the splitting of a heavy atomic nucleus, such as uranium 235 or plutonium 239, into two smaller nuclei, along with a few neutrons and a significant amount of energy. This energy is released due to the conversion of some mass into energy, as described by Einstein's famous equation, E equals mc squared. The fission process is exothermic, releasing heat that can be used to produce steam, which in turn drives turbines to generate electricity. This process is currently employed in over 440 commercial nuclear reactors around the world. As of today, nuclear power provides about 10% of the world's electricity and contributes significantly to the electricity mix in countries like France, the United States, and Japan. On the other hand, nuclear fusion is the process that powers stars, including our Sun. Fusion involves two light atomic nuclei combining to form a heavier nucleus, accompanied by a significant release of energy. Typically, fusion reactions look at combining isotopes of hydrogen, such as deuterium and tritium, to form helium. Fusion differs from fission in several key aspects. Firstly, the energy yield from fusion is much higher than that of fission. For instance, 1 gram of fusion fuel can provide the same amount of energy as 8 tons of typical coal. Moreover, fusion is seen as a safer and more sustainable process with a virtually limitless supply of fuel from seawater and no long-lived radioactive waste. Despite these advantages, human-made nuclear fusion has not yet become a practical energy source. For fusion to occur, very high temperatures and pressures are required, conditions that are challenging to achieve and maintain. Fusion reactors need to reach temperatures exceeding 100 million degrees Celsius to facilitate the fusion process, which has proven to be an engineering hurdle. One major fusion effort of recent times is the International Thermonuclear Experimental Reactor, ITER, which is being constructed in France with the collaboration of 35 nations. Its goal is to demonstrate the feasibility of fusion energy. If successful, fusion could provide a clean, safe, and abundant energy source. In conclusion, while both nuclear fusion and fission are ways to release energy from atomic nuclei, they are different in their operation. Fission is the splitting of heavy nuclei and is a mature technology used in today's nuclear reactors, whereas fusion is the combining of light nuclei and remains a field of active research with the promise of revolutionizing energy generation for future generations.